Hey guys, we had class today on Wednesday, November 3rd, and just wanted to let you know what we were doing. So just a brief video here. We first of all started by reviewing some of this stuff. So we looked at this circuit and tried to label all the different parts that are marked. So A is a switch, but then talked about what they did as well as a review. So that remember that switch was the thing that kind of opens up and it stops the flow of electricity. So we call that an open circuit. And then you wouldn't see any kind of light bulb go on. You wouldn't see any kind of electromagnet functioning. C is the actual wire that carries the electrical current from one place to another. We looked at F. That's the battery, so that's the source of energy. We weren't quite sure about B and D, if that was pointing at just the cell, the battery holder, or if it was trying to indicate we've got a positive and negative side of the power source. And then we've got the rivet here, which the coil is wrapped around to make this an electromagnetic current. The second thing that we reviewed, if I can get to it, whoop, not that one. Second thing that we reviewed were these different situations. And the question was, in this type of circuit, would the light bulb light up or not? And we said no to this one, because if you look at the wire coming in here and the wire on the left-hand side, they're both going to the sides of the light bulb, which is a contact point, but the other contact point is down at the base. You need to have one on the side and one on the base, and that's not happening. So this light bulb would not light up. And this one looks a little bit better, maybe. They're both at the base, but really, again, one of them should be on the side and one of them on the base, so this one wouldn't light up either. We got to this one, which has the battery kind of flipped to the side and the light bulb is laying on the side. This one would actually light up because you've got the wire going from one into the base, through the side of the light bulb, back into the side of the battery. Even though there's no wire there, those contact points are touching, so that would work. And then finally, this last one we said would not work. You can see the wire coming out to the side here. If the one thing that we would need to change is move that wire up to the side, so it's coming into the side of the light bulb through the base and back into the battery. All right, and then the last thing that we did as a bit of a review was just looking at these two designs, and you can see we've got a compass in there. And we looked at the compass and said, this one's pointing north-south, and then this compass is pointing east-west. Why was that the case? And the reason for it was that when the compass is just, we'll say, in its original position, this is an open circuit. There's no electricity flowing through it, which means that wire does not have any kind of magnetic field surrounding it, which means the compass is just sitting there as it normally would. However, when we on this diagram on the right, when we connected that circuit, it's now a closed circuit, so the wire has electricity flowing through it, which creates a little bit of an a magnetic field around it, and that changes the direction of the compass. Okay, so that was the first thing, just a little bit of a review for everybody. And then we got back into what the experiment that we had done on Friday. On Friday, if you watched the other video, you saw that we had listed all the different things that could have affected an electromagnet's strength. So we talked about winding it more often, winding it less often, use stronger batteries, or use more batteries, or a thicker wire, all that kind of stuff. So we reviewed the results of that. And what we found for the groups that had multiple batteries, they said this ended up becoming a stronger electromagnet. They were able to pick up about 6 or so more paper clips than they had just with their regular electromagnet. There was one group that said it actually got weaker, but we're pretty sure that's because they had flipped around the batteries. So as the electricity was flowing through, it went from positive to negative to positive to negative to negative to positive. So there was still electricity flowing through, but not the way that it should have been, and got weaker. And then we also talked about the one group that decided to have a different core, a different material for the core. So they just used rolled up paper as their core, and it basically picked up nothing. And said, well, if you kept that paper core, could you still make the electromagnetic strong? Well, we could by doing other things like wrapping it around more often, those sorts of things. Okay, so it was just a lot of discussion today, and then we played around with this, and I will link this. Online virtual electromagnet onto Google Classroom here for you so that you can kind of play around with it. What it does, let me see if I can drag this over. There you go. You can see it all better. You can choose between a thick wire, a medium wire, a thin wire. You can choose what kind of material that wire is made out of. You can wrap it a certain number of times. You can change the voltage on this, so higher or lower voltage. And you can change it from alternating current to direct current, AC or DC. I'll explain what that is in just a second. And as you're making those changes, what you're trying to do is get all these little metal shavings to get stuck to the electromagnet. So as an example, if you put this way up, you'll see some of these are flying up and getting stuck to the magnet. There's still 489 remaining. So play around with that and you can see which variables would allow your electromagnet to be a little bit stronger. Okay, and then finally, I want to show you what AC and DC is. So we watched this video, and what you're looking at right now is called direct current. And you notice that all the electricity is flowing in the same direction. And now it's switching. Okay, so I'm going to show you that again. In this case, when all the electricity is flowing in the same direction, we call that direct current, or DC. But if you have alternating current, the electricity flows one way and then comes back the other way, and then flows one way and comes back the other way. That's called alternating current. That's AC. So the difference between those two is also shown on this power supply. You can say, well, which kind of current would you like to have as part of this battery? So play around with that a little bit and review this video so you've got a better understanding of some of the dialogue that we had in class so that you're more prepared when you come back. That's it. God's blessings on your night.